Okay, in this lesson, we're going to start talking about a term called a matrix. And a matrix is simply a way of organizing data. It's kind of like a spreadsheet, kind of like in a Microsoft Excel spreadsheet or something like that. So again, each element in this matrix is simply a storage place for some data. Maybe you want to store, you want to talk about how many mattresses of each size that you have at two different stores or something like that. So it's just a simple way of organizing data. But by definition, a matrix is a rectangular array of variables or constants. These could be letters or numbers in rows and or columns. Now, rows run this direction. There's two rows here. Columns run this direction. The way I remember that is you have columns that hold up your front porch. Usually enclosed in brackets. So most of the time we're going to have brackets around these things. Elements. Elements are the individual values within the matrix. Element A, little a, if this is matrix capital A, little a of xy, to where x is the row and y is the column number where the element is located. So this tells you which row and which column that this element is in. Note, matrices are named using capital letters. So again, the capital letter is going to be the matrix. The lowercase letter that correspond is going to be the element. So given matrix A here, find the value of each element. Again, rows run this way. That's row 1 there. Columns run this way. So A of 2, 5 means what element is in matrix A in the second row and in the fifth column. So here's the first row, second row, the first, second, third, fourth, fifth column would be -2. A of 3, 1 would be the third row and first column. So here's your third row. First column would be the number 5. A of 1, 2 would be the first row, second column. Again, here's your first row, and this is first, second column would be the 40. Third row, fourth column. Here's your third row. 1, 2, 3, fourth column will be 52. A of 1, 5 is first row, fifth column. So the first row is up here. The fifth column would be a 21. And finally, A of 2, 2, second row, second column would be the number 32. Next up, let's talk about the size of a matrix. And we call the size of a matrix the dimensions. A matrix with m rows and n columns is said to be an m by n matrix. So starting on number 7, let's state the dimensions. So again, we call a matrix by row by columns. We name it with rows and columns. So this matrix has only one row. However, it has 3 different columns. So therefore, this is a row by columns. This is a 1 by 3 matrix. Number 8, row by columns. It has 1, 2, 3, 4 rows, and it has 2 columns. So this is a 4 by 2 matrix. Number 9, it has 1, 2, 3 rows and 4 columns. So it is a 3 by 4. And finally, number 10 has 2 rows and it has 6 columns. So it is a 2 by 6 matrix. Equal matrices. And I ran out of space here writing this definition. 2 matrices in which each element in one matrix is equal to the corresponding element in the other. So pretty much 2 matrices are equal only if every corresponding element is identical. Okay, some special matrices. First off, a row matrix. A row matrix is a matrix that contains only a row. So therefore, a column matrix would be a matrix that contains only a column. And it could have however many elements it wants, but that's a row matrix and a column matrix. A square matrix is a matrix that has the same number of rows as it does columns. So that's a 2 by 2 square matrix. And then a zero matrix is a matrix that contains all zeros. So that's actually, that last one is actually a zero matrix, and it would be a square matrix because it's a 3 by 3. Okay, add and subtracting. Add and subtracting, this is really simple, and it's just like with vectors. To add or subtract matrices, matrices can be added or subtracted if and only if, first off, they have the same dimensions, and we simply add or subtract corresponding elements. So therefore, x plus y, let's first check to see, can we add them? Do they have the same dimensions? And they do. They're both 2 by 3 matrices. So to add them, you simply add corresponding elements. 24 and negative 15 is 9. Negative 8 and 29 is 21. Negative 3 and 17 is 14. And then you simply continue on by adding corresponding elements, and that's what you get. Z minus W, our second one. Let me erase all of this. Z minus W, here is Z, and we're going to subtract W, do the exact same thing. It's a 3 by 2 minus a 3 by 2. So you simply do negative 1 minus negative 3, that's negative 1 plus 3, which is 2. 9 minus negative 2, which is 11. Negative 11 minus negative 16, that's negative 11 plus 16, which is 5, and continue on in the same manner. Okay, number 12, Z minus W. Now here is Z and here is W. Do the exact same thing. You have a 3 by 2 minus a 3 by 2, and you can subtract them then. Z minus W, this is Z, and here's W. So negative 3 minus negative 1, that'd be negative 3 plus 1, which is negative 2. Negative 2 minus 9, that's a negative 11. Let me close my brackets there. Negative 16 minus negative 11, that's negative 16 plus 11, which is negative 5, and then just continue on with the same set of steps. And there's what you get. Number 13, let me erase that. Number 13, W plus X. Here's W, here's X. They are not the same, so cannot add is all you have to put. And then number 14, X minus Y. Here's X. We're going to subtract Y. So we're going to, that's a 2 by 3 minus a 2 by 3. So X minus Y will be 24 minus negative 15, which is 39. Negative 8 minus 29, which is a negative 37. Negative 3 minus 17 is a negative 20. And then continue on, do the same thing for the next 3, and here's what you get. Okay, next step. Or the next section, scalar multiplication, same as vectors. Matrices can be multiplied by a constant, which is called a scalar. In this process called scalar multiplication, each element in the matrix is simply multiplied by the scalar to produce a new matrix. So it's just like, again, distributive property. Take everything in that matrix and multiply, in this case, by 3. So we're going to do 3 times matrix X. And to do that, again, we're simply going to multiply everything by 3. And that gives you 72, negative 24, negative 9, negative 12, 18, and negative 51. And that's it. Number 16, we're doing 3/4 times 3/4 times matrix W. And now let me copy down, here's what matrix W is equal to. So all we're going to do is multiply 3/4 times every element. 3/4 times negative 1 is negative 3/4. 3/4 times negative 11 would be negative 33/4. 3/4 times 8 would be 6. 3/4 times 9 would be 27/4, and just continue on, and here's what you get. Number 17 asks us to do negative 5 times X and then plus 2 times Y. And again, all you have to do is first off distribute negative 5 times everything, and then distribute a positive 2 times everything. And then just simply add the two matrices together. And there's what you get. Number 18, 4W minus Z. We're going to do 4 times matrix W. And then we're going to subtract matrix Z. So again, just follow proper order of operations like we did on the last problem. First step, let's multiply everything in matrix W by 4. And then we're just going to simply do minus matrix Z. And to do that, we're simply going to subtract corresponding elements, and there's what we get. Number 19, negative 3 times W plus Z. So W plus Z is in parentheses. Now we could distribute here and multiply them both by negative 3. The distributive property does work, but W plus Z, here's what we get. And I went ahead and added those two. And then we simply multiply everything by negative 3, and here's our final answer. And finally, number 20, we're going to do 1/2. We got to do matrix Y minus matrix X. So I'm going to go ahead and subtract those as I write it down. And then we simply multiply everything by 1/2, and here's our final answer. And we could leave that final answer as fractions, or we could change them all to decimals.